All right, I think we're still waiting for the core stand-up folks to come in, but hopefully soon. All right, well, we'll get started here, and then hopefully we'll get the core folks to come in once they're around. All right, so not a whole lot of new or updated performance PRs this week. Everybody's pretty focused on getting bug fixing done for our next release, Octopus. So we do have a couple of closed ones. Um, the first is a small optimization in the NVMe device backend for Blue Store, just removing an unnecessary AIO wait. There's also a small PR from Igor that adds log allocation stats. I think he was using that for his 4K min LX size testing and added that back in, so that's good. And then Casey merged this allow zone modified to config index shards PR, which is basically the one that changes the default number of shards for bucket indexes, amongst I think a couple other things that he added. But that's the piece of it that I know of. So that will be really good now that we have the ability to more quickly list bucket indexes when you have lots of shards. That should allow us to have more parallelism during writes and be able to improve performance when writing to a single bucket with lots of shards and lots of clients. All right, so that's basically it as far as what I saw that had really moved. I didn't make it quite through the whole no movement list there, but I don't expect a whole lot of other stuff probably got looked at this week. So any PRs I missed from anyone or any updates? All right. So the only thing I really have for this week myself is I have been continuing to work on testing Ceph with IO 500 and trying to get our scores up so that we have a good result that we can give to them. And one of the issues that I had run into previously was that the kernel client was showing slow read performance for like large sized reads. And I couldn't really figure out what was going on. Kind of talked to some of the SFFS guys about it. They didn't really know either. But I figured, well, maybe to do some comparisons, I'd look at the Fuse client. Well, the Fuse client was horribly, horribly slow for a variety of reasons, I think. So I thought, well, maybe I can go back and look at libcepfs. So I wrote a backend for IOR and MD test that ties directly into libcepfs. And I actually just got that working this probably about a half an hour before the meeting here. And I've got some initial results that I threw into the Etherpad. The gist of it is that it's significantly faster for large sequential reads. Whereas with the kernel client, I was getting about 30 gigabytes per second across our whole new Intel test cluster. With libceffs, I'm seeing about 65. So it's, at least in that specific case, quite a bit faster. It's quite a bit slower, seemingly, so far for file operations. So creating lots of files, deleting files, statting files, pretty much everything. We'll see what happens when I increase the number of MDSs, but it does appear to be slower for that kind of thing. Right now, the code is closing the connection every time a file is closed. And I'm not sure if that's actually the behavior I'm supposed to be doing. If that's correct, I'm kind of going based on the notes that I saw in libceffs.h. So anyone that knows, if you could let me know, that would be fantastic. But anyway, these are the early results that I'm seeing in the Etherpad here. So kind of interesting. Hopefully this will improve as time goes on, but it will at least provide us a good comparison point for the kernel client, if nothing else. So that's basically it from what I've got right now. Any comments or questions on that?
What do you mean you're closing the connection every time a file closes?
Well, I was looking at libceffs.h, and there's a comment regarding, let's see here, for Ceph shutdown, where it says this should be called on completion of all libceffs functions. So right
No,
now,
that just means when you're done. Like at the
okay,
end.
okay,
Yeah, no.
okay. So potentially then I shouldn't have to call that until basically IOR closes down.
Yeah.
I can just open it
That's
up. Okay,
probably if you're doing that, that's probably why the metadata's IO is slower.
exactly. Yep. And that's just bug on my part or error on my part in reading that. So uh, it will be really interesting to see how this does versus the kernel client once that's resolved, because it's looking surprisingly good so far, at least for the large reads and writes.
Well, yeah, you'd expect that. It doesn't need to go through the, kernel user space layer. And the reason that Fuse is slow is not because the user space code is slow, it's because the Fuse operations layer requires a lot of serialization and bundling and kernel user
Yep.
space calls and stuff. So yeah.
So my goal with this was actually to have this be basically the learning exercise to actually learn libceffs, and then after that, there's another user space file system kernel module that was written by some guys out at I think NetApp actually, but it's basically designed for significantly higher performance than Fuse, and I may attempt to write an interface for that.
You're not gonna get Zeus or ZooFS or whatever it is done, but
Yep.
but
You don't think
you
so,
can play
Greg?
around with it if you want. We've talked to them a
Well,
little bit. It's very complicated. Eventually,
okay.
maybe. Hope.
Well, anyway, at least at the very least, this might give us an idea of what could be possible with something like that if it, you know, if it ever did come to pass.
Yeah, it should be interesting to see the results. Are we allowed to use
Also,
anything like that for IO 500, or does it need to go through normal
yes,
file
we are.
patterns? Oh,
They
okay.
they did it. They did it for Deos, so this technically I think qualifies.
Awesome.
Yep. Also, we can play tricks then too, where like technically I don't think we're supposed to do like create the directories up front for directory pinning, if we do it as part of our libcepfs backend to mdtest and IOR, I think we can just like set the whenever we create the directories, we can just set the X adders right there ourselves, and it's fine. So we could like implement our own like custom round robin pinning right in
Oh,
the
that sounds
MD
like
test
cheating
layer.
so bad.
But it's like allowed, they let you do it as long as it's like at that level rather than like doing it up front beforehand. Seemingly so.
Hey,
They do stuff
the
like that
rules.
for like yeah striping, file striping. So so yes, this will be very interesting to see how this all shapes up. But it's looking hopeful. Well, that's all I've got for today, guys. I think we were talking about having Radek come in and talk about PG log stuff he was interested in doing with Crimson, but I guess maybe he wasn't able to make it. So, anyone else have anything they want to talk about this week?
Mark, I guess related to the PG log stuff, you were mentioning you did some experiments with removing the OMAP calls for it
Yes.
a while back. Can you remind me of the results about that? Or maybe send those to Radek too? I think he was pretty interested in those.
Yeah. Let me see. I think I made some spreadsheets for them. I did make a spreadsheet for them. I'll put it in the chat window here. We can briefly look at them now, and then we can send those to Radek as well. I remember I was also going to do this testing for RGW, but for whatever reason, maybe I did do it. I just didn't put them in here, or maybe I didn't get around to it. But this is at least for librd, so it's something. Um, Latency went way down. 99% latency went way down. Average latency was better, but not like to the same extent as tail latency. IOPS went up.
Forget that you have CPU usage
I
somewhere here too.
Yeah, if you scroll down, you can see IOPS per OSD core.
Oh, I see. Cool.
We're we were hanging around like 10 cores used in these tests for OSD, and weren't really getting any higher than that for whatever reason. But we did improve the number of IOPS per core, though maybe not as much as you'd expect.
Mhm.
Although having said that, the KV sync thread is only one thread, so
Right,
maybe it
right.
does make sense. Compaction time decreased fairly dramatically. Not really really dramatically, but like a decent amount.
Yeah, I imagine that's related to the tail latency as well.
Yep. That I think then probably means that we're leaking the pglog updates into the database, right?
Probably, yeah.
That would be my yeah. That would be my takeaway from that. So yeah, I think getting pglog updates out of RocksDB and into something else that doesn't cause lots of write amplification. uh, From this, looks like it makes sense to me.
Yeah, yeah, definitely.
Well, here, I'll send this to you and Radek. Anyone else you want me to CC on that?
Um, if you want to add the whole Crimson team, like,
Yeah, sure.
or I can just forward it.
Piece of attention, and if every like it was in the starter code, every
Sorry, Ronan, were you trying to talk? I couldn't quite catch what you were saying.
No,
balance
no,
so
no,
it's in
never
the
mind.
environment that you already.
Okay.
Oh, okay. Yeah, Josh, go ahead and feel free to forward it along and just CC me on it.
Sure.
Cool.
Thanks.
Yeah, no problem. All right. Well, that's all I've got, guys. I think we're all working on stuff for getting Octopus out. So have a great week, and we'll meet again next week. Thanks.
Thanks. See ya.
Bye.
Later on.